In today's video, we are going to talk about balancing redox equations in neutral medium. A prerequisite to today's lesson is the knowledge of the definition of oxidation and reduction. I made a separate video on that. You can check the link in the description below. To balance redox equations in neutral medium, we need a very popular method, and that method is known as half equation method. Some scholars refer to it as half reaction method. Here is the first example that we're going to use half equation method to balance. The first step we're going to take is to split the redox equation into half equations. Oxidation half equation and reduction half equation. How do we go about doing that? We check out for the common chemical species. Let's take a look at the reactant side. We have copper 1 ion here. And let's take a look at the product side. We have copper. Okay, so we can consider these two chemical species. So copper 1 is actually reduced to copper. So this is copper 1 ion, and that is actually reduced to copper. Okay, and let us consider the second half equation. And let's take a look at ion. We have ion on the reactant side. We have ion 3 on the product side. Okay, so that will give us another half equation. Ion is oxidized to ion 3 ion. Okay, now we are going to label this half equation. So we are going to label this as reduction half equation. Why? Because we have copper 1 being reduced to copper. The oxidation number is changing from +1 to 0. So this is a decrease in oxidation number. So that's how we're going to call this reduction half equation. And for ion, the oxidation state is changing from 0. It's changing from 0 to +3. Okay, the oxidation state of ion here is 0, and that of ion 3 plus is +3. So that's an increase in oxidation number. Alright, so because that's an increase in oxidation number, so we'll consider this as oxidation half equation. Alright, so the next step we're going to consider is what? In molecular balancing, we're going to ensure that the number of chemical species on the reactant side is the same as the product side. Let us consider the reduction half equation. So on the reactant side, we have 1 copper 1 ion, and on the product side, we have 1 copper atom. So that's balanced. And for the oxidation half equation, we have 1 ion atom on the reactant side, and we have 1 ion 3 ion on the product side. That's also balanced. So molecular balancing is done and dusted. Then the next step we're going to consider is electrical balancing. In electrical balancing, we use electrons to balance the charges. We want to ensure that the total charge on the reactant side is the same as the total charge on the product side. Alright, let's consider the reduction half equation. What's the charge on the reactant side? Copper 1 ion has a +1 charge, and copper has a 0 charge. Okay, then we take the difference. What's the difference between these two charges? So if we take the difference, 1 minus 0 plus 1 minus 0, the final answer is 1. So that means we're going to need 1 electrons to ensure that the charges are balanced. Since this is a reduction half equation, usually we add electrons to the reactant side. And we do that by adding one electron to this side. Alright, good. So we can see the one electron be added to the reactant side because it is reduction of equation. Or in other words, you can just consider the side with the higher charge. The reactant side has higher charge. +1 is higher than 0. So you add the electrons to the side with higher charge. Remember, the electrons you're adding is the difference. The number of electrons you're adding is equivalent to the difference between the two charges. Okay, oxidation half equation can give us better clarity. Let's consider the oxidation half equation. The oxidation state of ion on the reactant side, that's 0, and on the product side, that's +3. So ion 3 has a +3 charge. You can see it at the top here, so that's +3. Okay, so what's the difference? The difference here, that's +3 minus 0. Okay, the difference is 3, so therefore we are going to need 3 electrons. Since the difference between the two charges is 3, so we are going to need 3 electrons. Okay, so where are we adding our 3 electrons? It's an oxidation half equation. For oxidation half equation, you add the electrons to the product side. The electrons are added to the product side, or you consider the side with higher charges. So this side has higher charge, the product side has higher charge. +3 is higher than 0, so you add 3 electrons to the side with higher charges. Okay, so having balanced it electrically, so the next step now is that we are going to ensure that the electrons lost is the same as the electron gained. And if you look at these two half equations, in this case is 3. We have 3 electrons lost, and the electron gained is 1. We have 1 electron gained. And if you take the LCM of 3 and 1, and the LCM is going to give you. So that means what we want to do now, we want to ensure that the number of electrons lost is 3, and the number of electron gained is also 3. So how are we going to ensure that we have 3 electrons gained and we have 3 electrons lost? Obviously, 3 electrons is lost already, so for the electrons gained to be 3, so we have to multiply this by 3. Multiply the reduction of equation by 3. Okay, this is times 3. And the oxidation of equation, we multiply it by 1. So doing this will ensure that the reduction of equation has 3 electrons gained, and the oxidation of equation has 3 electrons lost. Alright, so let's multiply it through. So 3 times copper 1, so that's going to give us 3 copper 1. Okay, then we're going to have 3 electrons. Alright, and that's going to give us 3 copper 2. Okay, so this is going to be the same since we are multiplying through by 1. So we are going to have the same thing, Fe. That's going to give us Fe3 plus and plus 3 electrons. Alright, so the electron lost is now the same as the electron gained. So 3 is gained here and 3 is lost here. So what do we do now? We add the two half equations together. So reactant to reactant. So let's have it. So 3 Cu plus Fe. Okay. Then product to product to product. Okay, so we have 3 Cu plus Fe3 plus. Alright. So this is our balanced redox equation. So we can confirm that. Let's confirm if it is balanced. So we have three copper ion here, and we have three copper atoms. So our copper is balanced. And what about ion? We have one ion atom here, and we have one ion, three ion here. So our ion is also balanced. So we can consider the charge balancing too. So the charge on copper one here, that's going to be plus 3 because the charge on copper 1 is plus 1, but we have it in three places. So that's going to be plus 3. So this 3 is going to multiply this plus 1. So that will give us plus 3. So the charge on ion is 0. So the total charge here is a plus 3 charge. Okay. All right. So let's consider the product side. The charge here is 0. And the charge on ion 3 ion is plus 3. So 0 plus 3, that's plus 3. So charge wisely, this is also balanced. We have plus 3 charge on the reactant side and the plus 3 charge on the product side. So our redox equation is balanced. So here is our final answer. And we've confirmed that it is balanced. Okay, so that's our final answer. Now let's move on to the second example. We're going to split the redox equation into half equations. So we look for common chemical species. Okay, we have aluminium here. Okay, aluminium atom there. We have aluminium ion here. Okay, so aluminium is oxidized to aluminium 3. So we have this, and that's giving us that. Okay, alright, so let's consider the second chemical species. Okay, we have zinc 2 plus, and we have zinc. Okay, zinc 2 plus is reduced to what? To zinc. Alright, so obviously the oxidation state of aluminium atom is 0, and that of aluminium ion is plus 3. So there's an increase in oxidation number from 0 to plus 3. So we're going to regard this as oxidation half equation. So this is oxidation half equation. Okay, now the oxidation number of zinc 2 ion here is plus 2, and that of zinc is 0. Okay, so we have a decrease in oxidation number from plus 2 to 0. So we are going to regard this as a reduction half equation. Okay, now having done this, then the next step we are going to consider is what I call molecular balancing. We want to ensure that the number of chemical species is the same as we have on the reactant side and on the product side. So let's consider our oxidation half equation. We have one aluminium atom here, and we have one aluminium ion here. So that's balanced. Okay, let's consider the reduction half equation. We have one zinc ion, zinc 2 ion, we have one of it, and we have one zinc atom. Okay, that's also balanced. Alright, having done the second stage, which is molecular balancing, so the third stage that we're going to consider is electrical balancing. So here we are going to be using electrons to actually balance the half equations. Okay, so how do we go about that? We're balancing charge wisely. Alright, so let's take a look at the oxidation half equation. For the oxidation half equation, we have a 0 charge here for aluminium atom. And for aluminium 3 ion, we have a plus 3 charge. Okay, so we take the difference between the two. What's the difference? So the difference, we have plus 3 minus 0. And that is going to be 3. So the difference is 3. So therefore, we need 3 electrons. So where are we adding the 3 electrons? Because it's an oxidation half equation, we add the 3 electrons to the right. we add it to the right hand side of the equation. Or in other words, you can use the side with higher charge, the product side as higher charge. So since the product side has higher charge, you add the difference between the two charges. You add it in terms of electrons to the product side. The difference between the two charges is 3. So therefore we need 3 electrons. I'm adding it to the right hand side of the half equation because it's an oxidation half equation. Now let's consider the reduction half equation. Now for the reduction half equation, we have a plus 2 charge here and we have 0 charge on the right. So let's take the difference between the two of them. So the difference, we have plus 2 minus 0. So we have 2. So therefore we need 2 electrons. Okay, because it is reduction half equation, so we are going to put the 2 electrons, we'll add the 2 electrons to the reactant side. Electrons are usually added to the reactant side for reduction half equation. Okay, so I'll put my 2 electrons here. Okay, or in other words, you can say which side has higher charge. There's an higher charge here. We have plus 2 is higher than 0. So you're adding electrons to the side with higher charge. So either ways, you are going to get the same results. Okay, alright. So at this point now, we will proceed to ensure that the number of electrons lost is the same as the number of electrons gained. And that's a third step known as electrical balancing. Now, the number of electrons gained is actually 2. We have 2 electrons gained, and how many electrons are lost? 3. So 2 electrons gained, 3 electrons lost. So what's the LCM of 3 and 2? And that's 6. So we want to ensure that 6 electrons are lost and 6 electrons are gained. So how do we go about that? So that means we are going to multiply the oxidation half equation by 2. That will end up giving us 6 electrons. And we'll multiply the reduction half equation by 3. That will end up giving us 6 electrons. Alright, so let's do that. So put a bracket here, put a bracket here. So this will be multiplied by 2. Now put a bracket here, put a bracket here. This will be multiplied by 3. Okay. So 2 multiplied by aluminum atom. So I'm going to have 2 aluminum atom here. Okay. Alright. So I'm going to have 2 aluminum ion here. Alright. And I'm going to have how many electrons? I'm going to have 6 electrons. Okay, let's consider the reduction half equation. So we're multiplying through by 3. So 3 times Zn2 plus, I'm going to have 3 Zn2 plus. Okay, 3 times 2, I'm going to have 6 electrons. And 3 times, okay, I have 3 Zn. Okay, good. So the number of electrons now, the number of electrons gained is the same as the number of electrons lost. So 6, we cancel 6. Alright, so the final stage is that we are going to add up the reactant and the product. Okay, so let's have the reactant. We have zinc, we have aluminum, and we have zinc here. So we have 2 aluminum atoms and 3 moles of zinc 2 ion. Okay, so that's for the reactant side. So let's go for the product side. Okay, we have this, and we're going to have that. Alright, so 2 aluminum 3 ion plus what? 3 Zn. So we've succeeded in adding the reactant of the half equations together and the product of the half equations together. So these are final results. So let's confirm if it is balanced. Okay, we have 2 aluminum atoms on the right here. Good. We have 2 aluminum 3 ions. Okay, we have aluminum ions here. Okay, good. We have 2 of that. Okay, let's consider zinc. We have 3 moles of zinc 2 ion. Okay, We have 3 moles of zinc atoms. Okay, that's balanced. So let's take a look at the charges. Okay, we have 0 charge here. So we'll multiply this 3 by this 2. So 3 times 2 plus. So that's going to give us plus 6 charge. Okay, and the total charge on the reactant side, that's plus 6. Okay, let's consider the product side. 3 multiplied by 2 multiplied by 3 plus. So that's going to give us plus 6. And the charge for zinc, that's going to be 0. So the total charge here is also plus 6. Wow, so charge wisely, the equation is actually balanced. So this is our final result. 2 moles of aluminum atoms, 3 moles of zinc 2 ion, 2 moles of aluminum 3 plus, and 3 moles of zinc. That is our final answer. So in the next video, we are going to talk about balancing of redox equation in acidic medium. Thanks for watching. Bye for now.